All right. So Juliana, if I remember right, you guys were saying, like Dylan said really, really well. He's like, one of the reasons that it's best to figure out something like this on your own instead of having somebody else tell you, Nayeli, hi Nayeli. Dylan said one of the best reasons to figure out how to do something like this on your own instead of having somebody tell you is that you make your own connections. Because everybody does understand things in a little bit of a different way. It doesn't mean like somebody's right or somebody else's way is better, but we all make like slightly different connections because we all have different experiences. So that's a really good reason. And there's an even more important reason though. Because if you can make yourself use what you know to figure this out, then when you get stuck on a test, you're going to have the skill of being able to figure out how to do things that you don't understand. Which is even better because that's what happens in real life all the time. You have problems and you got to figure out how to solve them and you don't even understand. So making yourself understand and using what you know, it's a pretty big skill. Okay, so that said, let's just answer the question yes or no. Is this line, is this equation, this graph, do they match?
No.
No? Wow. Why not, Juliana?
Because if you plug in like the points into the equation,
Mm-hmm.
it doesn't need the.
So if you plug in points, it doesn't work. Okay.
Like the number
What about this one?
Yeah, that one does work, but the others don't.
Yeah.
One works, but the others don't. Okay. Hey, what's a graph? A picture of all the solutions. Okay. A graph is a picture of all the solutions. You guys sound like you're comfortable with that. Okay. So a graph is a picture of all the solutions. So that means if it's not on the graph, that it's not supposed to be a solution? Okay. And there's things on this line that don't match, like everything else except for this. Okay. So I believe you guys are right. How would you know, how many points do you think you should know for sure, like you should check?
At least 2.
Well, if you're graphing it, you need 3. But since it's giving us the graph, we probably could get away with 2. Because if they both are on there, then that's probably enough. Okay, so we're good with that. All right. No questions? You sure? All right. All right. Here's the thing I want us to understand today. Are you ready? This is the thing I want us to get our head around. I think it's going to be easy for you. I hope. All right, Diego, you ready? Here's the idea. We can draw a picture of all solutions to an equation. Usually. That's the big idea. That's what I'm hoping we get our head around today. I believe you guys probably actually have already been shown how to do this by steps. Probably. Yeah. Brandon, do you know how to do this? No? Okay. How many guys, like, you don't know how to do this? You don't know how to find the x and y intercepts and make a graph? Like, show of hands, you don't know how? Okay. A couple people. Yeah. All right. Well, so check this out. Here's what I would like to do. If you know how to do it, don't tell anybody, okay? If you don't know how to do it, I'm going to give you the idea, and I think you're going to figure it out really easy. Like, this is the same way that I teach Algebra 1 students how to do it, and you guys are, honors class, so I think you really get this. Okay. So the thing is, the question is, right? Like you guys got the idea. We're going to make a graph And the graph's going to be a picture of all the answers. We're going to make the graph by finding these, but the question is, how? How do you do that? That's the question, right, Tristan? So if you knew how to do this, then you could draw the graph, which is a picture of all the answers, right, Alex? Okay. So, well, here's the idea. Because x is 0 for all y-intercepts, right? You put x equals 0 and you solve for y. Yeah, because, right. Okay. Then you start over. You start all the way over, right? And then you put y equals 0. Solve for x. That's how. Yeah. So all you got to do is you find your two intercepts and you connect the dots. What's your question, Roberta?
What does the second, I think, sort of paragraph thing it says then the
Start over.
start over.
Yeah, you start over. Trying out my Espanol today. Conecta los puntos. Yeah. What's the matter, Parth? Huh? Nothing? You sure? Nothing, Parth? All right. So wait a minute. We haven't done a single example. And some of you guys know how to do this. Some of you think you know how to do this. Some of you are like, I don't know how to do this. Right? I have no idea if you guys know how to do it or not. I have some opinions, but I'm going to ask you a question that's kind of tricky. It says we can draw a picture of the solutions to an equation usually by finding the x and y intercepts. That means not always. So this method won't always work. When wouldn't it work? Anything where this would not work? Yeah.
When the equation's not linear.
Oh yeah. So, but let's limit it to linear equations. You're right. It's a little different then. Oh, yeah. Well, that killed you guys' thunder. Well, Alex, you still got something.
Yeah, like, well, it's usually 3 times x and plus 2 times something. Well, it usually, if it won't work when it's like y equals something, like y equals x.
Why not?
Like this, yeah, it'll just be 0, 0, 0. That's all it means.
Oh, wait a minute. So you're like saying if the x and y intercept were both 0, 0?
No, I'm saying go at something like that.
Wait, what?
Yeah, something like that.
That was funny. You started a statement. You started a sentence saying one thing, and then without stopping your sentence and starting a new sentence, you changed the meaning of your sentence. That's confusing. So he started off saying no, and then he said yes. So you're saying that, let me make sure I understand, and you guys, let's see if you understand what he's saying. He's saying that it would not work if the x and y intercept both went through the origin. They wouldn't work.
Well, no. Yeah, because it would just go like that. Yeah, it's just.
So you're saying you could draw a picture of all the answers to an equation if you had the x and y intercept and it went through the origin.
Yeah, it's everything.
Why not, Alex? Everybody's saying yes, and you're disagreeing.
1 point.
It's only 1 point, and you need 2 points to make a line.
You could do it like.
You could do it, but you need more information.
Yeah.
Because, like, for example, let's say that's it right there, right? Mm,
Oh, then where are you gonna draw your line? Yeah.
exactly. That's 1 point is not enough information to draw a line. You will be able to graph it, but you're going to need more information. Right. So you guys are right that yes, you will be able to graph it, but not by finding the intercepts. You need more. Dang, Alex. There's two other things that can happen. Now, I'm kind of surprised, Alex, that you came up with that because, well, that's tricky. But there's two other reasons that I thought you guys would come up with because we had talked about them already.
Is it when it's a curve?
No, that's nonlinear. I mean, that's true. That's trickier. But there's two other reasons that this won't work. There's two other examples.
When
Yeah.
there is no y or x intercept, like when it's like horizontal or it's just vertical? Yeah.
If it's a vertical or horizontal line, then it's only going to have one intercept. And it'll either be the x-intercept or it will be a y-intercept, but it won't be both. Yeah. Those are the situations where this won't work. And then you have to do other stuff. But in all other situations, this is easy. So let's try one. Let's try, you ready, Miss Beamer? Yeah? Let's try this. You try that one. 2x plus y equals 4. See if you can find the intercepts. Go ahead, Anna. You got this. You go, girlfriend. Wow, that is a very interesting way of sitting in a chair, Tristan. Wow, half forward, half backwards. Wow, Tristan. That's crazy. Have your skittle pox healed? Oh, mostly. Man, what if it leaves a scar? What if you have a skittle pox scar? You'd be the only kid in the universe had a skittle pox scar. That'd be hilarious. Yeah. Yeah. So find the intercepts and graph it. You okay, Kevin?
Is 0 positive or negative?
That's a good question. 0 is not positive or negative. It's absence of value. It's neither. Usually it's called non-negative, but it's not positive. It's neither. It's also non-positive, but you know, it's very confusing. Roberto, you okay on this? You got it? Or are you just sitting and waiting? Yeah. That's what we did yesterday. You gotta learn new stuff. So the thing you learned yesterday is really good, and it always works. It does. Yeah.
So we just plug in 0?
That's it.
Explain further. Alright.
4 plus 0 is not 4. It's the same 2 times 4 plus 0 equals 4.
Yeah. Okay.
That's what I've been saying this all the time.
All right, boys and girls. You ready?
Yeah.
Okay. So, I want to talk to you guys real quick about what Roberto said. He's like, I don't want to do this. I want to do just plug in numbers and find answers. Well, you can. And the thing about that, the thing about plugging in numbers and finding, it's called using a T-chart. The thing about that is it always works for any equation. It's beautiful. It's wonderful. The problem is it takes a long time. And there's patterns with different kinds of equations that we can take advantage of. So linear equations, they're straight lines. So since it's a straight line, if you find 2 points, then that's technically all you need to make a picture of all of the answers. So you don't need to do a T-chart. Sometimes you do. If you get stuck, you use a T-chart. For example, just like the one that Alex said a minute ago, if you had to graph that and you're trying to find the intercepts, Well, it's 0, 0. They're both the same. Then you could just use a t-chart to find a couple more points, and then you could make your graph. Okay, so Parth, this is called standard form. It's like ax plus by equals c, right? So a number times x plus a number times y equals another number. It's called standard form. Intercepts are super easy to find like this because, let's do the x-intercept first. You know y is going to be 0, so you just, you can cover it up and say 2 times what is 4? 2. You see? That easy. And then for the y-intercept, you know x is 0, right? So if that's 0, 2 times 0 is 0, so y equals 4. So y is 4, 1, 2, 3, 4. X is 2, 1, 2. Conecta los puntos. That's a secret. Okay. Abraham, supposedly this graph is a picture of all the answers. Let's say I was taking a test and I wanted to make sure I got a good grade, right? And I had a little extra time. Here's what I would do. I would pick another point, like that one, and I would just check it. Because that point right there, it's -1, 6. So I'm going to check it. So 2 times -1 plus 6. Let's see if that equals 4. Brandon, the mistake people make here, x goes first, but not always is x written first in the equation. And that you have to be very, very careful. It's so easy to mess it up. Sometimes y is written first, and then people just want to put this number where, replace the first letter they see. You got to make sure you're putting this wherever x is written and that wherever y is written. So this is true though, right? -2 plus 4, plus 6, that does equal 4. So that's true, that is a solution. And everything that's not on the graph, Nayeli, like this right here, 0, 0, won't be a solution. Because 0 plus 0 doesn't equal 4. We're good, Ms. Haro? Yeah? Okay. Fantastic. All right. What if you had the same exact instructions? We'll just do this. What if we had the same exact instructions, but it was now something like this? Graph y equals 2x minus 2 by finding the intercepts. Can you do it?
Oh, he got it already.
Try it.
Got it.
What, Anna? Just kidding. Wait, you can't shoot me a dirty look and then say, just kidding. Anna, if I had feelings, it would be hurt. Anna, don't be sorry. Just don't do it again. Okay. So yeah, we'll do it on the same graph. Azalea's already got it? No? Okay. What do you mean it makes no sense? Wait. Back the truck up. Abraham. Abraham. Do this, and then do that, and then you're done.
I just have to do that. I don't have to switch it around. So
What are you talking switch it around?
I don't know.
But it's easy.
Abraham, this is true always and forever. Do this. Do this. Got it? Good.
Wait, no, it's
Yeah. Mikey, you got this? What do you mean maybe, Mikey? Mikey, this isn't a bassoon. This is just math. That was funny right there. That was funny, Mikey. Mikey, that was a good one. You gotta admit it. Would I? I would love to, but I'm a teacher. I don't make any money, so you gotta pimp those somewhere else. He wants me to buy a gold card, which is funny because it's plastic. It's a plastic card. They call it gold, but it's not. They want $10 for it. All right, put it away. No. Put it away. Put it away. Put it away. Hey, Abraham, Avi, give it back to him.
Maybe so. I need to read it so I know if I should.
Yeah, you can read it in another class. Did you get these already?
Yeah.
What'd you get for the x-intercept?
1.
1, 0.
Yeah.
Okay, now it's a big deal. Like if it asks you for the x-intercept, don't say 1, because you might mix it up where it belongs. If you write the coordinate, you won't mess it up. Okay? I probably wouldn't mark it wrong if you said 1, but you will probably make a mistake later with like future steps if you only write 1. And then the y-intercept,
0 -2.
yeah. So yeah, you do have a little more work to do for the x-intercept when it's written like this. This is called slope-intercept form, right? It's called slope-intercept form. And that's why that's the y-intercept. Like you were taught this, y equals mx plus b, right? Like you guys know this, and you were taught that that's the y-intercept. But the reason that's the y-intercept is because x equals 0 for the y-intercept. So 0 times anything is 0, so y equals b. Yeah, so if I wanted to graph that, whoa, x equals 1, y is -2. Those two share a solution right there. Look at that. They share a solution right there. 0, 2. Or no, 1, 0. No. Wait. Oh, I missed. I hate my life.
Still share a solution.
They still share a solution, but it's not an integer solution. It's a fraction. Yeah.
What is it called when they share a solution?
No, they just cross.
Okay, because I remember they used to tell you this word.
They told you what?
Like, if you're buying, call it this word like when they cross.
Yeah, that's true, but that's different. You're talking about a system of equations, but that's a whole different. Some of the process is the same in finding answers, but a system of equations is different than one equation. A system of equations describes like more than one situation that works together. Like populations of predators and prey. If all the predators die, then all of the prey animals, like say all the coyotes die, the rabbits will eat all their food and then die too. Because they don't have anything to keep their population down. So they will eat all the food until it's gone and then they will all starve. Whereas if like a disease hits all of the rabbits, then the coyotes will also die because they won't have something to eat. So the population of each is determined by different things, but they are also related, and that's a system of equations. It's pretty complicated, like in practice. On a graph, yeah, you just see where they cross, and that's your answer, but it's bigger than that. But yeah, okay. What if grasshoppers had guns? Birds would be screwed. Birds would just be done.
What?
Yeah. What if grasshoppers had guns? Birds would be screwed because birds eat grasshoppers. Bird would swoop down to get the grasshopper would be like, get some, and then dead. Right, Anna? Okay. Yeah. All right. Shh. All right, boys and girls. All right. I know, it's very funny, right? Very funny.
If there's a point that doesn't work, but there's others that do, does that make it wrong?
Yeah. So something's going on. I'm glad you asked that. So she's like, what if we had a graph like this, right? And there was a point that worked, but the others didn't. And by worked, I think you mean is it a solution, right? Is there something wrong? And yeah, there is.
What if it's the other way around? What if there's like one that,
Doesn't work and everything else does? Something's not right. Something's not right. So the graph, every single point on the line should be a solution to the equation. And everything not on the line should not be a solution. Yeah, that's not just for linear things, that's for everything. Like every single point on a curve should be a solution to some graph or to some equation. Yeah, and that's why they get all funky looking. Funky. What's up, Diego?
How did they get 1 for x?
How do I get 1 for x? You put 0 for y. You put 0 for y. So you're going to solve this. You're going to put 0 for y, so it's y is 0, right? You're going to solve that. 2 times what minus 2 is 0? Well, wait a minute. What number minus 2 equals 0?
2.
2, right? 2. 2 minus 2 is 0. So 2, this has to equal 2. 2 times what is 2? 1. X is 1. Yeah. You gotta solve for x. Yes, sir.
Now that we're talking about all the curves in the line, I remember there was another term that we used if it got repeated, but they didn't tell us.
I have no idea what you're talking about. I have no idea what you're talking about.
They're like, use a pencil trick. Right?
I hate tricks. That's why ideas are good, but tricks are bad, because you're like, oh, I kind of remember this trick, but it, you know, tricks are for kids, not for rabbits. Okay, Brandon. Brandon, try this. Go ahead. Mm-hmm.
Then it's just horizontal.
You can't graph it.
Why not?
You can't graph it.
Try it. Go ahead. Try it. I'll let you guys talk to each other. Go ahead. I'll give you a minute. That's all it should take.
Yeah, no. It's just the vertical. No, it's
If y equals 2, so then you would just put it on the 2 and the line would go again.
It wouldn't be nothing.
That would be the y.
Unless you just have that why you are not part of the Why this is y equals 2.
So if y can't graph, a graph is of
It just has
all.
one.
So would it just be a point and it would be
There's the idea you have to understand about graphing, right? When you get confused or you get stuck. All right, listen, yes. When you get confused, Mikey, are you ready, Mikey? Okay. What are you doing? Are you pulling your tooth out? That's what it looked like. You stood up like suddenly with like great pain, and your whole hand was shoved in your mouth. And I'm like, did you just break a tooth? Oh, but you're putting rubber bands on your braces. You should put more so it like, you know, zips your lip. Zip ties right through. That's a good idea. Yeah. Okay. Brandon. Don't get so focused on how to make a graph that you forget what a graph is. You can't do that. Because the moment you get so focused on how, you forget why, and then you don't know what you're doing anymore. Then you're just focusing on steps and shortcuts and tricks. And you won't understand and you won't recall. So when we make a graph, we're making a picture of all the answers. And here's our equation, y equals 2. Well, y equals 2 is right here, which is great, but that's only one answer. Because we have two letters, right? We have an x and we have a y. So y equals 2 would also be like right here, 5, 2. And it would also be like right here, negative 4, 2. Oh, I missed. Okay, a couple things before Nayeli. Are you sitting sideways today, Nayeli? Are you doing like Brandon? Oh no. Oh no. Nayeli, you might be sitting sideways because you're like talking about math, but I'm not really sure. Oh, Brandon. Okay, Brandon, check this out. A couple things. When you're graphing, make sure your graph goes all the way across the coordinate plane and make sure it has arrows at the end. Big deal. The arrows at the end mean that it keeps going in that direction. Roberto? What's so funny? Did you see your grade? That was good right there. Focus, Roberto. Come on, focus. I know, right? Yeah. Okay. Tristan, you got grounded over your grade?
Yeah, for like the rest of the year.
Like for till the end of till December 31st?
No, the school year.
Oh, okay.
Wait, Tristan, was it your mother?
All right. So, Pierre, focus. Parth, focus. Don't let yourself get so focused on the steps that you're losing the idea. Because what's going to happen, and I promise this is going to happen, you're going to see a question on a test, and you're going to be like, I don't know how to do it. Just like happened on Friday. You got so focused on steps that you lost the idea. You have to revert back to the idea when you get stuck. This is the idea. That grounds what you're doing. That's what makes the steps make sense. In fact, that's where steps come from. Steps are just ways of addressing this. So we did learn yesterday, though, that if it says y equals a number, that it's going to be horizontal. We did that yesterday, right? We did. And its slope is, what is its slope?
Wait, rise over one.
Rise over run, that's good. So it'd be 0 over a number, right?
No, yeah,
And then
zero is equal to
But then,
because there's no.
1 times
But then-
1 equals 0.
Right?
1 times 1 equals 0? No, 1 times what?
There's no
0.
solution to it, so equals
so
0, right?
zero, it would be zero. Yeah, because
It's
one.
not undefined.
Yeah.
There is no slope.
It's 3 times 1 equals 15.
2 times what?
Yeah, so 1 times 1 equals 0.
What times 0? 0 times 10
Zero.
equals.
So would the slope be 0?
Is it 0 or
zero.
Which one is it?
Slope
Number
is
times
just
zero.
horizontal.
Look. Abraham, look.
You're on a flat.
All year, we have been talking about the difference between this and this. You have to get why, because you will forget. If you don't understand why this equals 0 and why this one is not a number, then you're going to forget. And it's more than this. There's more reasons than just getting answers to these questions. There's more reasons why you have to understand these. Yes, Abraham?
So if x equals a number and it was vertical, then it would be undefined slope?
Because that would be like this. You're right. Why is this undefined? Why is this not a number?
Because 0
0
0
equals
times
5.
nothing. 0 times nothing.
Yeah, there's no number times 0 that will equal 5. Right. That's why that's not a number. We say undefined means it has no definition. It's not defined as a number. But this one is 0 because 5 times 0 is 0. Right. Okay. So we're good. We're good. Okay. We think we're good.
When you go back to so we got slope because it's rise over run, so
Yeah.
not moving at all. So what do we put under it?
Well, the rise is 0. The run is whatever you want from. You could do from there to there. So that's 5. So 0 over 5. It doesn't matter. Like, yeah, it's a number. Yeah. You ready, Anna? You look really excited today. Okay. Find the intercepts and graph. Graph, right. Find the intercepts and graph. What's that?
Plugging 0 for x, do we ignore the subtract sign?
I don't know. It's a good question. Wow, I don't even know what's going on over there. Do you know what's going on over there? Over there. No, it's coming from over there. Sounds like people are swinging from the ceilings.
Yeah.
Wow.
When we're graphing, it's better to do mixed numbers, right? Instead of
It's up to you. Whatever makes sense.
What the heck?
I'm so confused. Because I have no idea what times 3.
5/3.
5/3.
Isn't 5/3 times 3 5? Write it down and see. See if 5/3 times 3 equals 5.
It was a 3.
Fractions are numbers.
I thought it was a 2.
This is a 2.
No, I thought it was.
You thought that was a 2?
I thought it was 2x.
what are you on?
And I just finished and I did the whole thing wrong. Are you okay?
You know what, Roberto? You just make up whatever problem you want and you do that one.
I'll just redo it.
Roberto's having a hard time today. He's having a hard time being us. He's having a hard time studenting, huh, Roberto? Hey, Parth. You know, man, we're having trouble with fractions again, it looks like. Not you, maybe, I don't know, but generally speaking. All right, let's do this. You ready? Check this out. Y is always 0 for the x-intercept. And here's the thing, Juliana. Sometimes you'll be given a coordinate like this, a number and 0. You have to recognize that that's an intercept. It won't tell you. Sometimes it won't tell you, but you'll have to recognize that because it's like an important fact that will kind of unlock other information for you. So you have to know way more than just how to do something. If it gives you an x-intercept and it doesn't tell you that it's an x-intercept, it should jump out and say, oh, I'm an x-intercept because y equals 0. Do you understand what I'm saying, Mikey? You sure, Mikey?
I don't.
You don't? Alex, you're going to be doing a problem sometime in the future, okay? And it's going to give you some information. It will give you, it might give you something like this, right? You're going to have to recognize that, oh, wait a minute, that's an x-intercept. Because there's going to be some meaning about the fact that it's an x-intercept, but it won't tell you that it's the x-intercept. That's a connection you have to make. Remember that we started the whole thing like, why is it better to figure out something on your own? It's because you're going to make connections. And your ability to make connections is what's going to make you a good problem solver. Dylan, what are you doing over there, Dylan? Huh? Huh, Dylan? Nothing. Okay, Dylan. Dylan, are you destroying the desk?
No.
What are you doing? You're your notebook. Okay.
Yeah.
You're not taking notes today, huh?
Yeah.
Okay, Dylan. Okay. Yeah. Mark Twain said, never argue with a crazy person because an innocent bystander won't be able to tell the difference. And he means between who's crazy and not. So you rock on with your bad self, Dylan. Yeah. All right, Pierre. Hey, Pierre, for this one, we're going to put a 0 for y. So we're going to get 3 times x minus 5 equals 0 because y is 0 and 2 times 0 is, right? So negative 2 times 0 is 0, so good. So x is 5 over 3.
Wait, what? I got 0 and 5.
Well, I'm sorry you did some RAM.
Yeah, I I took it back, yeah.
You have to do pentos backwards.
Yeah, you're solving. So you're going to add 5, right? And then you're going to divide by 3. Yeah. You guys, I was really surprised that with this kind of stuff, you guys are having trouble. Like, that's one of the things that caused so much trouble on our test on Friday. And it's just little stuff, but it makes a big difference. Okay, and now the other one. Let's see. Since x is 0, I'm going to have 2y minus 5 equals 0. So you're going to add 5 to both sides. So you're going to get negative 2y equals 5. And you're going to divide by negative 2. And there you go. Wow.
You could also put that as negative 2.5.
Don't, well, decimals aren't so nice. Fractions are better. So if you want to do it as, you could do negative 2.5, that's fine, but negative 2.5 is probably better. And this one is almost 2, this one right here, right? That's going to be 1 2/3. So 1 2/3 would be like right there. Negative 2.5 would be right there. Conecta los puntos, done. Yeah. What's up, Mikey? All right, you guys be quiet and let's listen to Mikey's question.
Why did you put the negative on the 5 and 5 over 2?
I didn't put a negative on a 5 over 2. It's negative. It is negative because look, it's this. This is what we have to solve, right? So it's negative 2 times what equals positive 5? And you're going to divide by negative 2. I didn't put a negative on anything. It is negative. You don't just get to put signs on stuff. That's like the wrong thinking. It is negative. It's like saying, why did you put the heat in the boiling water? No, it's there. It's boiling water. It is hot. It is an inherent property of boiling water. It's hot. This is a negative number. A positive divided by a negative is negative.
I think his question is that it's because it was started off on 2, but when you put them together, you put it on 5.
Oh, no. No. Fractions are numbers. That's a positive fraction. This is a negative fraction. This is the same as this, and that's the same as this. Yeah. No. Fractions are numbers, not operations. Fractions are numbers first and foremost. The whole thing's negative. Yeah. I'm glad you asked, Mikey. You're probably not so glad you asked at the moment, though, huh? Okay, Mikey. Fractions are numbers. Yes, sir, Mikey.
I have another question.
I'm glad.
On the graph,
Yeah.
I don't understand how you plotted the point.
You know who else doesn't know that? Abraham, because he's totally distracted. He's throwing stuff at Parth.
You stole my pencil.
Parth, give him his pencil back. Thank you. My God, I feel like I'm babysitting sometimes, Abraham. I'm going to have to just bring the duct tape and just tape your hands to your desk.
Mister, can I move? It's part of
Okay, yeah, sure. Where do you want to sit? You can sit. You pick your seat. What's your question, Mikey?
I don't understand how you plotted the points on the graph.
Okay, so we have these 2 points right here, right? Well, I made that a mixed number. That's 1 2/3. So 1 2/3 is in between 1 and 2. So I just guessed that it's going to be right there. It's between 1 and 2, but it's way closer to 2 than 1. Like if this was 6, 6 over 3 would be 2. That's a little bit less than 2. And then 2.5 is like right in the middle of 2 and 3. So 2.5 is right in the middle of 2 and 3. Yeah? Yeah. Fractions. Yikes. Now, Mikey, I'm glad you're asking these questions about fractions. There's a lot of people that I know for a fact in this room right now that fractions just destroy them. They don't even want to ask. It's sad because fractions are just numbers. You got to get around them. So you're doing the right thing, Mikey. They're confusing you, and you're fixing it. Yeah. Yes, Diego.
Why is it better to put it as a fraction rather than a decimal?
Decimals are approximations.
Yeah.
You can't actually write this as a decimal accurately. it's going to be 1.6 repeating, and you're going to round it, and then it's going to be 1.7, but that's not the same number. Yes, sir.
So if you're supposed to write the exact number for 5 thirds, do you find the common denominator so they both can be on the right place?
No. You're not adding. It's just 5 over 3 is going to be 1 2/3, or
You can give an approximate on the graph where it would.
yeah, you're approximating on the graph. That's true.
So they won't get it wrong.
No, that's right. Yeah. Roberto, and then the other. So rag and then reg.
Okay, so.
Oh, wait, reg and then rag.
Okay.
Sorry.
Okay, so you know how it's like supposed to be in the same graph? Would in the
What do you mean by it?
would you have like the same numerator?
Like, you don't need to get a common denominator for these. They don't matter. This is one point and that's another. You're not adding them or anything.
But like just like to make it easier.
Why would that make it easier?
Because it's like,
Why would more work getting a common denominator for these two things make it easier to graph?
because when you remembering it, like let's say, because they're both like in the 2 area or the 1, you number it as like 1 and then 1. Let's say you find the common denominator of 6,
How would that help you to draw a picture of all the answers?
1 6.
Wait. How would finding a common denominator between these two help you draw a picture of all the answers?
Oh, he's saying that because like then you can put the points on the graph, and then you can like one.
But it still won't work out like that.
Like, yeah.
It won't work out like that. Yeah, no, don't even try that. Like, this is just a number, and that's another number. That's it.
So how would you do that on the graph? Like,
Well, you approximate where that number fits. This is close to 2, so it's a little less than 2. And this is 2.5, negative 2.5, so it's right between 2 and 3, negative 2 and negative 3, right in the middle. And so you just approximate. Yes, sir.
well, earlier you were saying that decimals were approximations, right? What about 2.5 and 2.5?
2.5 terminates, it's perfect, it's fine.
Okay, so depending
But
on the,
only fractions that have a denominator that has a factor of only 2 or 5 will terminate. Everything else is non-terminating. So almost every single fraction is a non-terminating decimal. Yeah, like 1/3, 1/15, 1/11. Yeah, so it's 1/3, 1/4. No, 1/4 terminates because of 2, right? So 1/3, 1/6, 1/7, 1/9. It doesn't. It's got a 3. 1/15 doesn't terminate. 1/15 does. Watch, I'll show you.
Does 1/9 terminate?
Only if this denominator had prime factors of just 2 and or 5. With nothing else would it terminate. Yep. So almost all of them keep going.
so like 1/10 does terminate.
1/10 does. In fact, 1/10 is decimals are fractions with a denominator that's a power of 10.
You actually just said it, 1/10.
That's 1/10. I know. That's what I'm saying. This is 1/10. It's a different way of writing the same fraction. Decimals are fractions. They're stupid fractions.
What are decimals?
Decimals are fractions. Decimals are fractions where the denominator is a power of 10. So like 1/100th is 1 over 10 squared. It's 100th. So we did it like in the first day of school. Yeah. Okay. Allison, you got a question? What's your comment? Tell me. I want to know.
I forgot that one. 1 over 10 is 0.1.
That's weird, right? You get so used to decimals, you forget what they are. Yeah. Diego, you got a question?
Can you check it?
Can I check what? If my graph is right?
Yeah.
I could if I didn't draw it by hand. Yeah, like my graph right here is drawn by hand, right? So the scales aren't the same, so I really can't. If I did it on graph paper, then you're right. All I would do is pick a point. Ooh, I'm really glad you asked this, though. Check this out. Check this out, Diego. I'm going to put another graph up here. Let's look at this graph. Checking this graph, you want to find where your graph crosses at what's called a lattice point. A lattice point is where they cross like that. So it's like an integer solution. You don't want to check at a fraction because they're all going to be estimations. So you want to find a point where it crosses perfectly, like right here. And then you check that. Yeah. How you doing with that, Jesse? Excuse me. You're good? Okay. Hey, do you guys know how to graph by finding intercepts? Even if it's something weird looking like this? Fractions are okay. Okay. Yeah. Okay. Good, and you could do it with something like this. What if you had something like that? Could you graph that?
Yes.
Okay. You know what your homework is today? 10.2, number 1 and 2. 10.2, number 1 and 2.